Okay, y'all, so this video today is what I'm going to use to show people how to use Desmos, which is a pretty sweet free website you can do on a laptop, you can do it on your iPad, you can do it on anything. And we're going to use this to create a line of best fit that describes what's going on with the data. You all are going to be doing this lab where either you bounce the ball down and it comes back up a certain height, or you roll a car down the ramp and it slides to a stop. What we're trying to do is figure out the relationship between the starting position and the ending position. So if you did the ball bounce, you're seeing what height it bounced back up to. If you did the car lab, we're trying to figure out how far did it slide based on the starting position. And you're going to collect some data, but the thing of it is, you humans are always going to measure wrong, right? You are just not perfect. And so whether you're using a stopwatch or a meter stick or whatever, you're always going to have a little bit of error in your measurements. What we're going to do today is to use Desmos to fix that. We're going to use Desmos to kind of give us the better, cleaner, error-fixed data. So when we graph this data, just a quick review on this stuff. On the x-axis goes the independent variable. This is the stuff that you are controlling. These are the parts that you physically have control over. And so for our two labs today, that's going to be the release height, because you are changing the height of this ball when you drop it. Sometimes you're going to drop it from here, you'll drop it from here, you'll drop it from here, you'll drop it from here. Same thing with the car. You let it slide from there, from there, from there, and from there. And so you are controlling where this thing started from, and so we're going to graph that on the x-axis. The y-axis is going to be our dependent variable, and these are the ones that depend on what you've done down here. That's why I call it dependent. And so for our lab data today, this will be the final position of the ball, because as I drop this thing from different heights, here, 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 and here, the amount of height that it's going to bounce back up is going to change. As you release this thing from here, 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 here on the ramp, it's going to slide to a different amount of final position right there. And so you're going to collect some data. I would suggest at least 5 trials, and I would do it 3 times from each and take the average. When you plot these things on Desmos, what you're going to see is that your data is actually going to be kind of messy, right? It should be on a nice straight line, something that looks like this, but because you're humans, what we're going to see is that the data is off, right? You didn't measure perfectly. So like if this line is representing what's really going on, it looks like you were a little bit high with that measurement, and this measurement was a little low, and that one's a little low, and that one's a little low, and looks like that one's a little bit high. What we want Desmos to do is the math for us, where it's going to say this line right here, this is the perfect model. This is explaining what should have happened if we were better at measuring, and this thing is going to give us back an equation of y equals mx plus b, slope-intercept form of a line. So to do this in Desmos is pretty darn simple. You start by going to desmos.com, and you're going to make, I think you might even have to say, graphing calculator. Great, so here we are. We're going to get started. I'm going to come up here to this plus, and I'm going to add a table. And I've got these coordinates on here, y and x. And it's going to say x1 and y1 because you could have multiple sets of data. We've just got one. So on the x-axis, I'm going to just make up some numbers right now. Let's just say 1, 2, 3, 4, 5. Oops, that's supposed to say 3. 5 and 6. And in the y-axis, I'm going to make up some numbers. I know ahead of time. This isn't real data. This is just some stuff that I'm making up. So I'm going to say 2.8, and I'm going to say 7, and I'm going to say 8, and we'll say 12.45. How about 16.1 and 17.6? Great. So what I've got here is some data. And sure enough, it looks like this is kind of in a nice straight line. If you want to adjust the zoom on this thing, you can come in here to settings. And my x-axis, I want to go for 0, and the y-axis doesn't need to be any bigger than about 10 or so. There. So this looks a little bit better. You can tell that these kind of follow a straight line. What I want to do, though, is get Desmos to give us the equation that is the best fit line. I want it to say, yeah, they're not in a straight line, but this is what it should be. And to do this, I'm going to come over here and say, give me a new expression. Now, this expression should be y equals mx plus b. The only problem is it's not going to be perfect. It's not going to be exactly right. What we want to do is say, give me the line that y1 and x1, those are our data points, best fit. And so we're going to change y equals mx plus b to y1 and x1. And all I have to do is just type in the the one, it automatically does subscripts for me, but they're not going to be equal. I'm going to use that. That's a shift apostrophe thing over to the left of your 1 right there. What this is saying now is I want you to give me the line that best fits y1 and x1. And you can see it automatically drew the line on there for me, and this is fantastic. So in this case right here, it looks like I have a data point, well, you guys, you can't see where my hand is. The data point at x equals 2 is a little high, and at 4 and at 5, they're a little high. But this does a really nice job. This line is right smack dab in the middle. And if I come over here where it says parameters on the left-hand side, I have an M of 3.02 and a B of 0.08. Okay, so what that means for my data is my line of best fit, y equals 3.02x plus 0.8. Right, so if this was my card drop lab, this would be my release height right there, and this is going to be my final position. This tells you the formula for how far your car is going to go based on where it started. And you all get to do something like that. Of course, what I'm going to ask you all to do is to hit a target. So I'm going to ask you to go here. Well, you might have to work backwards then and plug it in for x, but that's fine. It's just a little bit of algebra. We can do that, and I will help you with it. Anyway, hopefully this helped.